Hi everyone, we are group 2. So right now, I am your Kuya Pa. Right now, we'll tackle about polygon. Polygon is a two-dimensional closed figure bounded by straight lines. So, most of the basic shapes such as triangle, square, rectangle are parts of a subset of closed figures bounded by broken lines. And these are called polygons. The term polygons came from the combination of Greek words. Poly means many and gonia means angle.
There are different parts of a polygon. Number 1, side or edge, one of the line segments that make up the polygon. Number 2, vertex is a point where the sides meet. Number 3, diagonal, a line connecting two adjacent vertices. Number 4, interior angle, angle formed by two adjacent sides inside the polygon. Number 5, exterior angle, angle formed by two adjacent sides outside the polygon. Number 6, apothem of a regular polygon is the segment connecting the center of a polygon and the midpoint of a side. The apothem is also a perpendicular bisector of the side. Last, the central angle of a regular polygon is the angle subtended by a side about the center.
In classifying a polygon, there are three major conditions that are needed. First, it must be a two-dimensional figure. Second, a polygon must be a closed figure. Lastly, it should be bounded by three or more straight lines.
Polygons are said to be similar if their corresponding interior angles are equal and their corresponding sides are proportional. Let's take this figure as an example. Polygon ABCDEF and polygon UVWXYZ. Angles ABCDEF are congruent or similar to angles UVWXYZ. These similar polygons are noted with this one. Thus, angle A is congruent with angle U. Angle B is congruent with angle V. Angle C is congruent with angle W. Angle D is congruent with angle X. Angle E is congruent with angle Y. And lastly, angle F is congruent with angle Z. Then by ratio and proportion, we obtain different equations from the two similar polygons. So first equation is x sub 1 all over y sub 1 is equal to x sub 2 all over y sub 2. Wherein x sub 1 and x sub 2 are the two sides of the similar polygons, while y sub 1 and y sub 2 are the corresponding sides of the similar polygons. And the next equation is a sub 1 all over a sub 2 is equal to x all over y squared. Wherein a sub 1 and a sub 2 are the areas of the two similar polygons, while x and y are the corresponding sides respectively. There are three types of polygons. Number 1, simple and complex polygons. A simple polygon has only one boundary and the sides do not cross each other, otherwise it is a complex polygon. Number 2, concave and complex polygon. A convex polygon has no internal angle more than 180 degrees. And if there are any internal angles greater than straight angle, then it is a concave polygon. Number 3, regular and irregular polygons. Regular polygons is whose sides are equal and whose interior angles are congruent. Thus, a regular polygon is both equilateral and equiangular. If otherwise, the polygon is said to be irregular.
And now the exciting part in studying polygons is that it has many different names. Polygons is named based on the number of sides. A polygon that has 3 sides is triangle. 4 sides has a name of quadrilateral. 5 sides has pentagon. 6 sides has a name of hexagon. 7 heptagon, 8 octagon, 9 nonagon, 10 decagon, 11 undecagon, 12 dodecagon, and the proceeding based on their numbers. Example in constructing the polygon names is the polygon that has 21 sides. In naming it, you just add the prefix of 20, which is ecosa, plus beside 1, which has the suffix of henagon. So, we name it ecosa, henagon. And the other polygon that has 22 sides can be named like ecosa daikon, which means the prefix of 20 was ecosa and the suffix of 2 was daigon. In naming, we have the prefixes that has a name of ecosa in 20, 30 has triacon, 40 has tetracon, 50 has pentacon, 60 has hexacon, 70 has heptacon, 80 has octacon, and besides 1 to 9 has a suffix name like the 1 has henagon, 2 has daikon name, 3 has trigon name, 4 has tetragon name, 5 has pentagon name, 6 has hexagon name, 7 has heptagon name, and 8 has octagon name, and 9 has enneagon name.
Two of the most practical applications in polygon deal with perimeter and area. When we say perimeter, it is the length around the boundary of a closed two-dimensional region, while area is the amount of materials needed to cover a surface completely. The formula for perimeter is P is equals to S times N, where S is the value of side and N is the number of sides. While the formula of area regular polygon is A is equals to side square N over 4 cotangent quantity of 180 degrees over N.
Drop the funky bass.